Okay, we're going to pick up with factoring. This time we're going to specifically look at the difference of two squares. All right, when you're looking at these, if you're new to it, and that is supposed to be two squares, make sure that you understand what this is implying. When it says difference, this only works with subtraction. You cannot do this with the sum of two squares. It doesn't work. Basically, let's figure out the why, and then we're going to go from there. Why in the world does this do? We'll start from, where does this stuff come from? If I have x minus 4 and I have x plus 4, if you multiply all that out, and you can use the concept of FOIL, or you can use the idea of distributing. Personally, I like distributing because it works no matter the size. Start with your x and distribute times the other set. X times x, x squared. X times 4, 4x. Now come back, get your negative 4, x, and negative 4 times 4 is a negative 16. Now, check this out. These two factors cancel. And why do they cancel? Well, if you go back to where they came from, they're always going to have opposite signs. One's going to be negative and one's going to be positive because the problem's set up that way. If these two numbers are the same and the signs are different, they're going to cancel. So these go away and you're left with x squared minus 16. Now check that out. Do you see that x squared is a perfect square? X times x gives you x squared. 16 is a perfect square. 4 times 4 gives you that. So this is the difference, because it's subtraction, of two squares. Now, notice where it came from. It's going to be set up where you do the square root of the first one in the front. You do the square root of the second one. The square root of 16 is 4. It goes in the back. And your signs are always different. Nobody really cares which one is positive, which one's negative. Just make sure that one of them's positive, one of them's negative. The order doesn't matter, is what I'm getting at. But you get that. It's the square root of the first, square root of the second, different signs. Every time. So, as long as you look at it and you're like, okay, the square root of x squared, that's a perfect square. The square root of 25, that's 5. So both of them are perfect squares. It is the difference. Verify that it's subtraction. You do square roots in the front, square roots in the back, opposite signs. And you can keep going. They can get a little bit more involved. If you had 36 x squared minus, let's see here, 49y squared. Looks a little messier, but you can do it. Everything's perfect squares, so just go with square roots. Make sure you're verifying, hey, this thing is subtraction. The square root of 36 is 6, so we have 6x and 6x. The square root of 49 is 7, but you do have to accommodate the y squared. So we have 7y and 7y. One of them's minus, one of them's plus. Just beware whenever you're doing these, if you come across one that looks like this, if you kind of get in a hurry and you're going too fast on your homework, you might blow by these and mess up. If this thing's a plus sign, you need to see that. It does not work with a plus sign. You'll never get one to factor out. These are prime. So just write prime. The reason why it doesn't work, remember, if you go back to what we did up here, and I realized I kind of went crazy with the colors there. The negative 16, where did the negative come from? The fact that there is a negative on this 4 and a positive on that one. When you multiply a negative and a positive, you get a negative number. So the 16, the back number, will always be negative because your signs are opposite. So it has to be subtraction to work. I do want you to be careful because you can take this and the common factor and mix them together. So if I had 36x squared, and let's see here, I subtracted 4y squared. Yes, you could do square root of 36, and yes, you could do square root of 4. but when it's all said and done, you're not going to have this thing completely factored. We need to get in the habit of always checking to see if there's a common factor. 36 and 4, yes, there is a common factor. So try to pull those out first. 4 goes into 36. Now let's see what remains. 36 divided by 4, that would be a 9. We didn't mess with the x's. And then 4 divided by 4 is 1, so that's just y squared. Now, what remains actually falls under your difference of two squares rules. So the square root of 9 is 3, and the square root of y squared is y. You have one of them's minus, one of them's plus. So this is completely factored. So I want to make sure that you get the difference. If most of the time you are asked to completely factor something, that means this has to be pulled out. So if you came in here and all you did was 6x and 2y and 6x and 2y with a minus and a plus, this is not completely factored. Because if you look in here, there's a 2 hiding, and there's a 2 hiding in there. 2 times 2 gives you this 4. So pull your common term out first. Let's do one more of those just to make sure that everybody's on the same page. If we've got 100 x squared minus 25y squared. Well, 25 goes into both. If you take 25 out, that leaves 4x squared minus y squared. So keep your 25. You cannot throw that thing in the trash. Just bring it all down. You can now factor the inside according to the difference of two squares. So there's your 2x, a 2x, a y, a minus, and a plus. Now you are completely factored. All right, that's all there is to the difference of two squares. Just make sure that you've got the thing with the subtraction in it.